So right off the bat, the 3's can go away. And if I rewrite this as 1 square root, I'm going to get 5u cubed over v and 2 u cubed over v cubed. So the u's go away, 1v on top, and I get 2 left inside. So I get 1 over v, square root of 5 halves. And then it says I have to rationalize the denominator, so that means no square. So let me just rewrite this. So this is the square root of 5 over v square root of 2. So I don't want any square roots left in the denominator, so I'm going to multiply by the square root of 2 over the square root of 2. So I should get the square root of 10 over 2v. Okay. Yeah. Okay, next one. So I'm going to get 4 times the square root of 6b cubed over 15b cubed, which is going to equal 4 times the square root. Let's see, 3 goes into 6 2 times, and then 15 5 times. And then, oh, that's a b squared. So sorry. So those b's go away, and I get left with 1 on top. So I can rewrite this as 4 square root of 2b over the square root of 5. Rationalize the denominator. So I should get 4 square root of 10b all over 5. Any questions so far? Are we okay? Okay, so number 3, oh great, it's a 4th root. Okay, so I have 4th root of 10n squared over 135, which I can simplify to 4 times the 4th root of 5n squared over 27. I just divided by 5. Oh, not 5 on the top, sorry. 2. 5 goes into 10 2 times, not 5 times. Wow. Okay, so then I can write that as 4th root of 2n squared over the 4th root of 27. And in order to get rid of the root in the denominator, I need a 3. So the 4th root of 3, because 27 is 3 cubed, right? So I just need one more 3. So 4th root of 3. So I should get 4 4th root of 6n squared all over 3. Whew. And then what do I need in this denominator? A 5 and an x. So but there's only one square root, so I'm just going to rationalize the denominator. So I've got the 4th root of 5x, because 125 is 5 cubed, and then x cubed. And I need 4 of them, not 3 of them. So 4th root of 5x. So I should get 4x, 4th root of 5x, all over 5x. And then my x's will go away, so I should have 4 4th root of 5x over 5. Questions? Those ones were super hard, harder than anything that you would have done on your homework anyways. Okay. So today we're like adding and subtracting and multiplying basic things with roots, okay? So when we're adding, so it says add or subtract, simplify by simplify by combining like radical terms. If possible, assume that all variables and radicals represent positive real numbers. So when we're adding and subtracting radicals, I want you guys to kind of think of them as variables. They have to be the same underneath the square root sign. So not only do they have to have the same root, it has to be square root, cubed root, whatever, that has to be the same, but what's underneath it has to be the same in order to add them or subtract them. Okay, in order to multiply them, they don't have to be, but in order to add and subtract, they have to be the same underneath it. So this part here has to be the same. So this all has to be the same. So they're both square roots of 5. So I can say 6 square root of 5 plus 2 square root of 5 equals 8 square root of 5. Okay, does that make sense? If they're not the same, I can't add them together because they're not like terms if you want to think of them as like terms. Okay, so on the second one here, my like terms would be the 7s and then the 5th root of 2's, right? So I just do whatever it tells me to do, right? 5 square root of 7 plus the square root of 7 is 6 square root of 7. And then negative 8 5th root of 2 plus 9 5th root of 2 would be the 5th root of 2. Questions? Everyone at home okay? Everyone here okay? Okay, so if they're not the same, guess what? We need to simplify the square root to make it look the same or try and get it to be the same. So on number 3, right, I can rewrite 50. 50 is, what is 50? 25 times 2, right? So the square root of 25 is 5. So this becomes 9 times 5 square root of 2 minus 4 square root of 2. So 45 square root of 2 minus 4 square root of 2 equals 41 square root of 2. Everyone okay with where the 45 came from? Because that's usually where people get confused. So I bring it outside and it's 9 times the square root of 50. So once I bring the 5 out, it's 9 times 5. Okay. So if I'm doing 5, I'm going to do the same thing. Now they're both different. I have to just simplify both square roots. So let's see, 12 is, what is 12? 12 is 4 times 3, and 27 is 9 times 3. So I've got 5, square root of 4 is 2, square root of 3 plus 16 times square root of 9 is 3, square root of 3. So that would be 10 square root of 3 plus 48 square root of 3 equals 58 square root of 3. Questions, anybody or everybody? Okay, so there's 6 problems. Let's see, what have we got here? Kind of make it bigger. Okay, so 4 plus 7 is 11 square root of 3. And then my roots are the same. So I've got 7 minus 5 is 2 cubed root of 4. I guess I should say equals. And then C, they're still all the same. So I've got 8 minus 2 is 7. Plus 5 is 12 square root of 2. Okay. And then once we come down here, we're going to have to simplify some roots. So 27 is 9 times 3. So 4 times 3 square root of 3 minus 3 square root of 3 would be 12 square root of 3 minus 3 square root of 3 is 9 square root of 3. Okay. And then, let's see, E. We've got a cubed root here, and 16 is 8 times 2. So that's 3 times 2 cubed root of 2. And 54 is 27 times 2. Yeah, that's right. So that's plus 3 cubed root of 2. So that should be 6 cubed root of 2 plus 3 cubed root of 2 should be 9 cubed root of 2. Any questions so far? Okay. And then F should be, let's see, the cubed root of 27 is 3 minus 5, and the cubed root of 8 is 2, so that's 3 minus 10, or negative 7. Any questions? Not too bad so far? Awesome sauce. Okay, next. Now we're going to multiply, so we're going to do the same thing, only we're going to multiply. The only thing we have to be careful of when we're multiplying is that they're the same root. So square root times square root is fine. Cubed root times cubed root. I can't multiply a cubed root and a square root together, so they've got to have the same root, okay? So I'm just going to distribute just like we do if they're whole numbers or variables. So that would be 3 square root, oh, sorry, I don't know where the 3 came from. Wow, the 3 came from inside the root. Let's try that again. 5 cubed root, a square root of 3, wow, plus the square root of 6, 2 times 3. So I multiply what's on the outside of the roots together and then what's on the inside of the roots together. Okay? So, and we'll, do I have something like that? Of course I don't. Of course. Why would I have something like that? That would make too much sense. So if there was like a 3 on the outside of this, when I distribute this through, I'd multiply the 2 and the 3 together on the outside and the 2 and the 32 on the inside. That's what I mean by if you multiply what's on the outside together and then multiply what's on the inside together. Okay? So let me erase that. So if I distribute, this is all cubed roots, so we're good to go there. So if I multiply this through, I get the cubed root of 8 minus 2 cubed root of 64. Yeah, that's right, 64. And I'm pretty sure the cubed root of 8 is 2. Minus 2 times the cubed root of 64 is 4. Yeah. So that's 2 minus 8 or negative 6. 64. 4 times 4 is 16 times 4. Yeah, 64. Okay. So now if it's if it's a binomial or 2 times 2, I'm going to FOIL, or I can use the box method. It doesn't matter how you multiply it, so I'll do one each way. It doesn't matter. I have a couple to do. So I'm just going to distribute, right? This times this, and this times this, and this times this, and then this times this, right? So 4 times 2 is 8, and 4 times the square root of 5 is 4 square root of 5. And then negative square root of 5 times 2 is negative 2 square root 5. Minus the square root of 25. Now I'm going to simplify everything. So I should get 8 plus 2 square root of 5 minus 5. So my final answer should be 3 plus 2 square root of 5. Questions? Okay, so this one I'm going to do, I'm going to do this one doing the box method, because sometimes I like that a little better. You guys can do it whichever way you choose to do it, right? So I've got the square root of 12 plus the square root of 5. and then the square root of 12 minus the square root of 5. So if I multiply these together, I get the square root of 144, which happens to be 12, right? And then minus the square root of 60, and then the square root of 60, and then minus the square root of 25, which happens to be -5. Is that right? Yep. So my whole answer should be 7. 12 minus 5 is, yeah, 12 minus 5 is 7. And then square root of 60 minus square root of 60 is 0. So I got 7 out of that one. Okay, so kind of like that one a little better because I can do everything, all the work inside my little box before I combine my like terms. Just, you know, whichever way you like to do better. It doesn't matter. So I'm going to do number 5. And I'm going to blow this up bigger. Thanks. So I've got 3 square root of 10 times 3 square root of 10. Because remember, what does it mean to be squared? To multiply by itself, right? So I'm multiplying it by itself. 3 times 3 is 9. And then I get 3 square root of 10 and 3 square root of 10. And the square root of 100, which is 10. So if I add my like terms together, I'm going to get, let's write it up here, 19 plus 6 square root of 10. 9 plus 10, yep. 3 plus 3, yeah, okay, there we go. And then number 6, I'm just going to do the same way. Because it's my preferred way doesn't mean that you have to do it that way. I just want to put that out there. So I get the square root of 3 minus the square root of 2. And the square root of 3 minus the square root of 2. Okay, so I've got the square root of 9, which gives me 3. And negative square root of 6, and negative square root of 6, and the square root of 4, which gives me 2. So my answer should be 5 minus 2 square root 6. Questions? From home? Anybody? Nothing? You guys okay? Does it make sense? Okay. Good. All right, there's 6 problems to do. Ooh. So number A is 3 square root of 30 minus 3 square root of 35. Done. Number B is 9 cubed root of 2. Oh, hold on. That's the wrong B. My bad. Helps if I actually choose the right problem to give you the answer to, huh? B, there we go, is 3 minus 4 cubed root of 63. Maybe I should just cross those ones off so I don't write the wrong answer again. C is 4 plus 3 square root of 6. Oh, and then D is fun. D is the square root of 6 minus the square root of 14 plus the square root of 21 minus 7. And there's nothing in common. Can't simplify anything. Done. Okay. E is 23 plus 8 square root 7. Yeah. And then F is 2t plus 2 square root of 10t plus 5. Any questions? T plus 10t is 2. Okay, yeah. Are you okay with that? Not too bad? Awesome. I know I keep saying too bad. Sorry. So on the last one they want us to do is rationalize the denominator again. Remember, I can't have square roots in the denominator. I'm still going to multiply by 1. Only this time I'm going to, every time I do this, I forget the word. I have it right there, and then I forget about it for a couple days. I'm going to multiply by 1, but what I need to do is I need to take this number right here, this whole number, and I need to multiply by the opposite side. So 4 plus, I'm going to change the middle sign. So 4 plus the square root of 5, and that's going to be my 1. And it's called, dang, I almost had it again. 4 plus the square root of 5. Okay? So if it was 4 plus the square root of 5, then I would multiply by 4 minus the square root of 5. So I'm only changing the sign of the middle number. Whatever happens to be that middle, whatever that middle sign is. So if this was a minus 4, I'd keep that as a minus 4 no matter what. Okay? So I'm only changing the sign of the middle one. So now I have to multiply both 2 times. Okay? So I'm going to distribute through the top, and I get, what do I get on the top? 5 times 4 is 20 plus 5 square root 5 in my numerator. And then in my denominator, I'm just going to come over here. And I'm going to multiply by 4 minus the square root of 5 and 4 plus the square root of 5, right? So I've got 16, 4 square root 5 minus 4 square root 5 minus the square root of 25, which is minus 5. So my square roots of 5 go 4 square root of 5 minus 4 square root of 5 is 0, right? So that goes away. So that's 0. And I get left with 16 minus 5 is 11. Done. So there's no more square root in the denominator. That's what happens when I change the sign in the middle. Those square roots go away and they make a 0, right? So that's why it's called rationalizing the denominator. Okay, so we'll do it one more time here. Do I need to wait a second so you guys can write that down? Or are we good? Okay, so I'm going to multiply. I'm just going to change the sign in the middle. So it's going to be square root of 5 minus the square root of 2. And I'm going to multiply by the same thing. So I'm actually multiplying by 1. Right? And then I'm going to do the top first, I guess. So square root of 7 times the square root of 5 is the square root of 35. And then minus the square root of 14 plus 5 minus the square root of 10. Okay. And then on the bottom, I'm going to get, what am I going to get? I'm going to 5 minus the square root of 10 plus the square root of 10 minus 2. So I should get 5 plus the square root of 35 minus the square root of 14. It does not matter what order I write those in. The whole number doesn't have to be in front of the square roots. It doesn't matter. I could write it exactly like this again. It doesn't matter. Okay, so there's not a, like with the complex numbers, it says the whole number has to be in front of the imaginary number. Remember that? With square roots, it doesn't matter. You can write it either way. And then on the bottom, 5 minus 2 is 3. So that's it. Kind of ugly. So let's go ahead and have you guys try this. Got 3 problems there. If you need me to show you why, if you have a question on one of them, let me know and I'll do the whole thing on it. So number A should equal 18 plus the square root of 2 divided by 7. Okay. Number B should equal A minus the square root of AB all over A minus B. Ugly, but true. And then C should equal -1. Everyone okay with that? Any questions whatsoever? We're good? Awesome. Okay, so there's a Delta Math assignment. Also don't forget to do the self-eval for extra credit. Some of you guys need the extra credit. Please do the self-evaluation form. It's found on the Canvas page. That's how you're getting extra credit this term.